We can examine continuity from the left and the right just as we can examine limits from the left and the right. So a function will be said to be continuous from the right at a if we can say the limit from the right of f of x is equal to the function value at a. And conversely, it'll be continuous from the left at a if the limit from the left of f of x is equal to the function value at a. So let's do an example of this. We have a radical function. It's even. The index here is even. So we know that the domain must stay greater than or equal to 0. The radicand must stay greater than or equal to 0. So 4x squared must be greater than or equal to 0. And this is a non-linear inequality. So we can't just solve across the equal sign. What we're going to have to do then is we're going to have to find critical values. And remember, those occur, 1, when the function is undefined. We don't have any of that with a radical function, so we don't have to worry about that. And they also come from when you solve the equality. So let's do that now. So instead of solving 4 minus x squared is greater than or equal to 0, we're going to solve where it's equal to 0. So 4 has to be equal to x squared, so x must be equal to plus or minus 2. And these are our critical values. Now we can place those critical numbers on a number line, minus 2, positive 2. We can fill those in because that's where the function's equal to 0. We'll need to pick test values in each interval, pick some easy ones, say maybe -10, 0, and positive 10. And we need to evaluate those. So let's see what happens at -10. Let's plug it into the original inequality and see what happens. So 4 minus -10 squared, and we're going to ask ourselves, is that greater than or equal to 0? Well, 4 minus 100 is not greater than or equal to 0, so this is false. So our inequality is not true on that interval. We can plug it into 0, or plug in 0, our next test point. So is 4 minus 0 squared greater than or equal to 0? And sure, this is true. 4 is greater than or equal to 0. So that means it's true, our inequality is true on this interval. And let's pick our last interval, positive 10. So is 4 minus 10 squared greater than or equal to 0? That's clearly false as well. So the only place that our function is continuous, then we can read from here, our function is continuous on the interval from -2 to positive 2. Now we have to answer the question we were asked. We're asked, where is the following function continuous from the left? And we can see then we can't approach the function from the left this direction because the domain is not defined there. So we can't approach from the left at x equal 2. So we can say f of x is continuous from the left at x equal to 2. Of course, we could also answer the right-hand question too. We could say f of x is continuous from the right at x equal to -2.